Hi, I'm CJ and this is my RC channel. Okay, I have drilled the horns. As I mentioned, I drilled a row along the bottom, and I actually decided not to use the hole at the top. I drilled down about maybe 1.5 millimeters, 2 millimeters, just to because the control horns in the fuselage are so short. I want to be able to have a lot of flap action if I want, so I wanted to shorten the horn a little bit and get a little more leverage there, a little more action. And the way I did that was using this set of micro drill bits. These start at 2 millimeter and go down to like 1/10 of a millimeter. It's a little hand drill, and it really works great for these kinds of things. Now, you have to bear in mind that when you're drilling, whether you're using a power drill or hand, sometimes the hole is going to be a little larger than the drill bit because of any, movement in an elliptical, direction as you're drilling. And so I would start, let's say, for example, these pins here were 2 millimeters. So I started with a 1.5 millimeter drill bit and enlarged it with a 1/7 to get a nice snug fit where it moves, it rotates freely, but it doesn't have any jiggle in it, because any jiggle means that you're going to have some off neutral changes, and that's something you want to avoid at all costs, especially with small gliders like this. Then I took a 1.1 millimeter drill bit and I drilled some holes in the two small horns that go for the rudder and the elevator. The one with the hook, you don't need to drill. This is for your elevator, your stabilizer, so that you can take the screws out and remove it. You need to be able to disconnect the line, which means pulling the loop off of here. If you are going to do that, make sure that you've got some tape or some other means handy of securing that loop, because if it drops back into the fuselage, you're screwed. You're not getting it back out again. So you'd really have to rip things apart to try to, and you'd have to run a fresh line. I mean, what else could you do? Anyway, also this hole here at the top was extremely small, and I enlarged it to the 1.1 millimeters. I was doing the other holes since I had the bit in there at the time. I wanted to make sure I was going to be able to feed the line in here cleanly, because it has the potential to fray, because it is a wound multi-thread or multi-wired line. So that's what I've done so far. Now I'm going to do the fuselage drilling, and I will show you that. This little thing here comes with this little pair of tweezers to help you fish the bits out. It has been a godsend. I bought it at one point for a very specific need for very small holes, stuff that was less than 1 millimeter. And I have used it again and again. It actually goes up as high as 3 millimeter, but it's just got a ton of bits. And when you get down to the 1.1, then you get into all these bags of individual bits that are, well, there's usually several in the bag, but like 0.07 millimeter, 0.08. They go down to let's see, 0.09, 0.03. Is the smallest one I can see from here, but I think 0.05, so you get the idea. Anyway, it is a great little hand drill, and there's just I seem to use it on almost every kit, and in one place or another I find a use for it, or it lends itself to it. It comes in handy. So one of the many one of the many modeler's tools that you should try to add to your collection over time. Okay, where are we at now? Well, I have cut the holes in the slots in the fuselage. I decided to drill 2 holes and then cut the space between them. A combination of razor saw and X-Acto knife completed this process. It is very thin material, so it's not difficult. Just make sure you take your time, because you could really open this thing up badly if you rush or push too hard or use the wrong tool. I have run the 2 wires, the 2 pull cables, and I've taped them one to either side, and likewise here at the rear I've taped them one to either side. Now the way to do this correctly is to feed from this direction going forward. Take the cable and cut it in half. Feed one end in first. Get it down to the nose, pull it over the side, make sure you've got lots of slack to work with and plenty at the rear, and then tape it off to one side. Then tape the rear off. Once you've got that one in place and it's taut, do the next cable. That way you don't have to worry about them crossing or winding around each other. Ideally you want them to be, you know, a straight line, no interference from each other. Okay, so with those 2 in place, those are ready for me to put into the 2 horns here. As you can see, I also have the push rods for the ailerons. The Z-bends are in place here and here, and I've cut the 2 pieces of Bowden tubing. As you can see, one of them is shorter than the other. That's because the 2 servos are a distance apart, so there's going to be equal amount through the tubes. Basically they're both going to come out of here at the same distance, and so the longer one will be for the left hand side, where the horn is further forward than the one on the right. So then we have the when I start sliding this into place, that's when I'll do my loops. I'll like feed it in part way, do my cables, crimp them, and then continue sliding it into place. The wing, I have done the cutting. I wanted to show you one side after the cut to show you how I did it. I basically laid down a thin piece of masking tape. I measured about 1/8 of an inch back, measured the length of the horn, and then this part I just used an X-Acto knife. The material is extremely thin, and cut your rectangle, do the lengths first, and then cut the cross cuts to connect them and pull it out. Clean out the little bit of foam, and sorry, someone's at my door. Okay, anyway, so as an example, this horn will slide right in, and all I need to do is mix up some 5-minute epoxy, and those holes that I drilled are really going to help make sure that this becomes a permanent resident and can't pull free. So that will get glued in place just like that. The other one, you want to make sure that they're both the same distance of depth, because if they're not the same depth, you're going to have one with more throw than the other, and you don't want that. So these will get glued in. I would try to glue them not perpendicular to this surface. I would try to make them perpendicular to the center line, or parallel to the center line. So in other words, a little bit of an angle like that. I hope that's obvious, as you can see. Because the wing has dihedral, so you don't want to have this perpendicular to the wing, because you're adding that angle of the dihedral. So stand it straight up and down, like a vertical center line to the perpendicular to the horizon might be a good way to describe it. Now, one of the things I may need to do is I may need to pull these cables and rerun them, because I haven't glued the Bowden tubes in, and I don't want to get any glue on these wires and attach them. So I'm probably going to pull them back out. I'm going to slide my Bowden tubes in like this. I'm going to put some 5-minute epoxy around them and glue them so they're just sticking out about 1/8 of an inch like that. And I may also glue them onto the side rail here a little bit, just tack them in 1 or 2 places. So yeah, I'm going to go ahead and do that. I'm going to pull the wires, because if I glue one of those wires in place, that's ruined. So it's easy enough to run them a second time. So you don't need to watch me doing this. So I'll go ahead and stop the video. I'm going to move on to these steps one at a time. And so everything's going to come together, you know, kind of quickly, because everything needs to go in at the same time. When I put those servos in place, I have to have my cables, my pull cords looped through and crimped. I have to have my aileron push rods ready to slide into the Bowden tubes. And I need to have my battery wire plugged into the receiver and ready to go, because once this is attached, I'm not going to be able to make any changes to the receiver. So that's one of the reasons you want to bind up your receiver early in the process and get it over with, because you can't bind it once if you're using the layout I am using, you're not going to be able to bind later. Now, if you don't want to use my layout there, what you can do is move these servos further back, and you can try to mount a receiver either on top of the servos or up in the nose, and then stack the battery on top of the servos. That's an option. I've seen a couple different installs, and what I've got going here is by far the cleanest that I've seen, as far as not having wires everywhere that might interfere with pull cords and such. But I don't want to knock anyone else's build. I mean, if they've got it functioning and the plane flies, then they did just fine. So you know, everyone does things their own way to a certain degree, and what counts is, does it work? At the end of the day, if the plane flies, if all the controls work without any problems, you know, good on them. So as you can see, I didn't cut through the top surface at all. And that's easy enough to do if you're just, you know, put in a fresh blade and be gentle with it. Just, you know, poke the tip through and then slowly saw your way down, and you'll get through this, because it's hard to poke through it initially, but it does cut quite surprisingly easily, because it is such thin fiberglass, and I think it's only one layer of fiberglass material on top of the foam. So the aileron linkages, the horns here, are glued in, and they are nice and solid, and I've glued in the horns on the tail section and attached the first of the 2 springs, and I wanted to show you how to do the springs, so I left one undone. So what you want to do is you're going to need a needle nose pliers, and you want to identify the fold for your hinge. In the case of the stabilizer, the spring is to keep it open, or keep it in the down position, and you pull to put it into the up position. So fold it down like this, and you can't fold it flat on itself. The rudder, you can fold it almost flat onto itself, and you want to hold the spring with the needle nose pliers, put it about middle of the of the wing, or of the stab, and you want to pierce the tail section. And what you're going to want to do is push it in. You don't want it to come out either side, so you want to push it in straight into the surface. So, I'm sorry about that. Just get the camera to sit still. So, about there ought to do it. So, I got it started. Don't want to put it in all the way just yet. Now you want to do the other side. You want to push that all the way down. Okay, now, as you can see, it wants to stay open, and you pull it, and you've got a nice solid spring action there. And it's definitely got a lot of force to give you, good down elevator, so that shouldn't be an issue. And pull it back for up elevator, so that's all ready to go. So now it can be bolted on, and the line can be attached. And this is going to be a little trickier than I had thought, because remember I said I'm going to be attaching the line in here, doing my loops first at the front, attached to the servo, and then do things at the tail end. The problem with that is that, I'm just going to try and hold this flat as best I can. When you are attached here, you can see that I'm sorry, let me move the camera. You can see that the horn is actually inside the rear boom, so there's no way to do it by hand at the rear for that. You've got to make that loop first, and that makes it really tough to try to remove this at any point, because you'd have to disconnect the front to get enough slack to be able to pull that out. So that's kind of a tough one, but so I may need to do the elevator first up front. Excuse me, at the rear, do the rear loop first, and then make my loop in the front. And in that case, then that is going to dictate which servo I use. Now I can use either of these for rudder. I'll need to make a few changes to my setup if necessary, for stabilizer. And as I recall, this one already is set up as stabilizer, and that would be the one I would want, because I want the one that's furthest away from either of these two entrances, so I've got some room to work. So I'll need to very carefully loop that through, line it up, and crimp it with tension on this, so that I get it as close to being a flat surface as possible. Now, something you're going to want to do when you're not using the plane, you're going to want to release the tension on these springs as much as possible, so they don't lose their strength over time. So what you should do, at the very least, if not disconnecting them, you should be, when you turn it off, push the servo all the way to its extent for being for releasing the tension. So in other words, when you're about to turn off the radio, give it full down elevator and full left rudder would probably be correct. And that way, when you turn off the radio, it stays in its relaxed position. It wouldn't be completely relaxed, but at least you'd have it mostly relaxed, and that'll help keep that spring you know, tight. It'll keep it from loosening over time. So anyway, we'll cross those bridges as we get to them. There are certain things that you just can't do anything about. For example, the fact that this is inside the actual fuselage. I was hoping that, and I don't know why I hadn't thought about this earlier, but in any event, the rudder is no problem because the rudder is completely exposed. So the rudder will attach the loop at the front, and then when we glue the rudder in place, we're going to have easy access to the horn. Now, when I cut my horn slot, I did it straight in line with this, but a little lower. So it's, I put it about an 1/8 inch down from the boom. So it's going to come out of the tube here, out of the boom, and basically just go straight back. So I didn't want it just like rubbing up against here or catching on that surface. I wanted it to just come just below it, just to make sure that tension is always constant. So again, you know, like with this one, I actually cut a little slot here with a razor saw to turn this this rudder horn into a hook, also just like the like this one. It's not as strong because it's a fairly small amount of fiberglass here, but I think it's going to be fine. If it becomes a problem down the road, I'll you know, replace it with a new one or something. But this way I can take the loop off of the rudder and let the rudder fold back into it, so the spring is completely relaxed. So this is where it's going to start getting interesting, where I've got to do all these different connections. I've got to slide these. I used the wires that came with it just to keep my Bowden tubes aligned. And I just want to kind of do a test on that right now. See how that's going to go together. So what I'm going to have to do is kind of slide all this stuff together. I'm going to have one of my two tail feather loops done, the other one ready to be done. There's a lot going on here all at the same time when I'm going to put this in, so I'm kind of going to do a little trial fit here. Just kind of show you what's going on. And I attach the Bowden tubes, just to tack them to the side here. That may be a problem. I may need to free them up. I may not. Got to get that out from behind there. Yeah, so this looks like it's gonna slide together nice and easy. I don't want to put it in right now, so I'll need to get some two-sided tape, but I'm going to leave it somewhat in position here. Actually, I might as well pull it all the way out because I have to still do my battery connection. But as you can see how I'm sliding it in like that, it's all going to go in together. It's going to, you know, you got to manipulate it a little, but you can already see that the aileron push rods are sliding out through the Bowden tubes that are glued in place. I've got my cables tacked to the side, so when I'm about this phase here with this hanging out, I'll untape the one for the stabilizer, and I'll, excuse me, for the rudder, and I'll go ahead, loop it, and crimp it. And then I'll take the one for the stabilizer and I'll loop it through, but not crimp it. I'll just kind of hold it and, you know, kind of tack it in place, or maybe tape it to the side. Just, it's got to be stuck through there so I don't have to try to feed it through once it's in the fuselage. And then once I slide everything in, I take up the slack on the stabilizer. I use some of those little swizzle sticks and rubber bands that I have to keep this flat and have this screwed in and have the loop done at that end. Then I can pull tight and have those little metal tubes ready to crimp around the line at this end and lock that down once this is slid into place. It's I hope that's kind of starting to make some sense. It'll make more sense as you see it going together. It does build up very quickly. I am moving through this stuff fairly fast now that I've worked out a lot of the how am I going to do this or that problems, and I think you'll find the same for yourself. Now, one thing you can do with these springs is put a drop, I mean a small drop of thin CA in the hole to help anchor this into, because it'll wick into the foam and help lock it down. But you don't want to put in a lot because you don't want to tighten up the hinge or anything like that. So the process is coming along. I used a crimping tool that I have and some pins and servo plugs, and I basically made a 2-wire servo plug, positive and negative. Modern receivers these days will take power into any available port, whether it's the bind port or an auxiliary port, it doesn't matter. So if you need to plug in a battery, you can do that. You can even split into a servo and provide power to the receiver that way. Anyway, I also did the batteries. I basically just split into the existing line and soldered in. I've still got a little drawing here. It's just liquid tape. This one is dry, and so that's basically going to be sitting up in front here. And as you can see, there's enough wire for the lead from the receiver to meet up to the lead for the battery, and there's a little slack left, so it's not going to be tensioned. So it should be easy enough to plug these two together and just leave them, you know, up in the air above everything, out of the way in the middle underneath the canopy. So there was something I found when I screwed on the stabilizer just to kind of test things out. I didn't tighten it down hard or anything, and when I went to move this through its range of motion, you hear that? That is the that's this fiberglass horn touching down on the inside of the fuselage boom. When I talked previously about making a spacer and moving the stabilizer a little further away from the boom to allow for a more acute angle, it's something that is actually necessary in this case. I thought I had glued this in all the way to the bottom of the stabilizer, but either it's a little tall or I didn't glue it in deep enough. I'm pretty sure I glued it in deep enough, so I'm going to say it's a teeny bit tall. So if you don't want to use a shim, bear that in mind. So I'm going to make a shim that will move this away. It just needs to move it a little bit. That'll do two things. It'll give me that steeper angle for my up elevator that I wanted anyway, and it will prevent the horn from rubbing against the inside of the boom. So I'm going to go ahead and take care of that, and it looks like my little pod here, my little assembly of electronics is all ready to go. It's nice and neat, it's clean, everything. There's nothing that's moving around except for the antennas. So nothing's going to catch on any of the linkages. So everything should go in nice and smoothly. That is the next step, but there's things that have to be done before it as part of this process. I need to tie a loop of line for the rudder here. I need to thread the elevator line through, but not tie it off. And I need to make a loop back here and crimp that down so that's ready to go. So that end will be just loose through this end here. This is my elevator. And then I can slide this all into place. I'm going to attach it with I'm just going to use a strip of, sorry about the jouncing camera. I'm going to use a strip of Scotch brand. It's basically a rubber-like two-sided tape. I wanted to use something with a little bit of a sponge effect to it so that when pressed it will fill in the little holes in the fiberglass. I have cleaned this area very thoroughly with denatured alcohol and a towel. Did that a couple of times, let it dry, did it again just to make sure I got anything out of here as far as mold release and whatnot that might prevent this assembly from attaching. I don't need to put anything on the receiver. There's a stop or something in the fuselage that prevents the receiver from going back any further than it already needs to go. This is going to anchor down to the floor, and then the battery will just sit in between the servo and the nose. It's pretty much a perfect fit. It's almost as if this stuff was designed to work that way. And the servos aren't going to go anywhere. I mean, I almost think that even if they came loose, I would still have some control over the airplane because they can't really go anywhere. If it did loosen, it's going to be pressed between the battery and the all these wires and the connectors for the receiver, so it couldn't possibly go anywhere. You know, it might move a millimeter or so in one forward or backward, or jiggle a little sideways or whatnot, but I wouldn't be surprised if I still had enough control over the airplane to be able to land it. But I don't expect that to happen. One of my regular viewers asked if this tape was going to be an issue with the two-sided tape because it's very shiny and kind of slippery looking. But this 3M tape pretty much grabs a hold of anything. So I have used two-sided tape and this tape together in the past on other things. I'm not worried at all. In fact, my only concern is that if I ever need to take this out for any reason, I'm screwed. I'm more likely to break the fuselage than I am to be able to pry this thing out. The only way to possibly get it out would be to cut the tape, get all the wires loose, then cut the tape that is holding the servos to the board, pull all of them out, and then slowly work the board loose from the fuselage. When I refer to the board, I'm talking about this yellow piece of fiberglass that comes with the kit that is a nice mounting deck for these servos. So I'm really pleased. I highly recommend anybody who is approaching this kit use the Bluebird servos. I think there may be one other brand of servo that's small enough. I think I saw one in a build that someone else did. Almost any servo, micro servo, is going to be too big for this. A lot of the traditional micro servos, even some of the high-end all metal, you know, the red ones that have like the base of the motor exposed, even those guys are probably a little bit big. These Bluebirds are really teeny, and it's the height of them that matters because they have to lay flat in the fuselage. So you might be able to find a servo that's a little narrower or not as long, but it's this measurement here that is critical, and that's where those turniges just failed. They were not going to work. It would have been a horrible effort trying to get everything in, and in the end things would have been scraping against the sides, and it would have been a nightmare. I don't believe it would have ever actually flown properly with those servos. They're just too big, and the fuselage is too small. So all good to go here. Got a couple of batteries. I'm gonna make my shim for the stabilizer, check that for clearance, make sure that the stabilizer moves freely and nothing is rubbing, and then I'm going to start doing the pull cords, and then installing this assembly into the fuselage. And that's the real critical part right there. This is, you know, once I put this in, I've got to make sure I've thought of everything else. I need to think about what I'm going to do with my antennas. I've got to think about everything. What I'm probably going to do with the antennas is I'll put a small hole in the top here, and I'll loop one of the antennas back like this and let it poke through the top like a whisker. With 2.4 gigahertz radios, the best way for these antennas to be arrayed is at a 90 degree to each other. So I'll probably have one coming out the side of the fuselage, and so it's coming out laterally, probably at a little backwards angle, and then the one that loops back coming out through the top. I did that on my last glider, worked great, no problems with reception and whatnot, so all good. Just for those of you who've been following my other videos, the Fresh, it flies great. I took it out for a maiden the other day, and my wife was not doing a very good job with the camera, and I was wearing my GoPro on the bill of my baseball cap, and I either forgot to turn it on, or it shut off on its own because I was trying to run it at 4K and 60 frames a second, and that may have been a mistake because sometimes those GoPros just don't cooperate at the higher settings. I mean, I love the thing, it's great, it's been doing really well for me, but every once in a while something goes awry. I was controlling it through my phone using a Bluetooth connection, and I'd swear that I turned it on, but I obviously need to be double and triple checking that, and so I didn't get any good footage. I got about 8 or 9 nice hand-thrown flights, adjusted the trim a little bit. My CG is set at between 68 and 69 millimeters from the leading edge, and I think I need a little more nose weight because I had to add a decent amount of down trim, and it still seemed a little floaty, and I'd prefer it to penetrate better. I think a nose-heavy plane versus a tail-heavy plane is always the better option if you have to go one way or the other. So I'm going to add, you know, a 1/4 ounce or, you know, just a few grams of lead to the nose and take it out for some more flights and see how it goes, and I'll let you guys know. I hope you enjoyed this video. Please click like and please subscribe to my channel.